I'm going to teach you about recursion, and also we are going to learn about basic GUI. So I know that everyone is pretty much busy with the last day of Ramadan, where tomorrow is going to be our Eid celebration. Okay, but since everyone wants me to record this session, why not I just stream it and then just leave it there. Okay, so it won't be long because there's no one here basically. So first of all, we are going to learn about recursion, okay, and then we will go for the basic GUI, okay. So let's begin with the recursion. Recursion. Before we learn about recursion, we first need to learn about iteration. Okay, what is the difference between iteration and recursion? Okay, recursion basically means a function calls itself. Okay, so let me just take out my Wacom. Sorry, I forgot to set up first beforehand. That's okay. Okay, so what is recursion or iteration? Okay, iteration is basically loops, all while loops or do while loops. Anything that we can give a parameter to loop itself. Given that a certain statement, it loops itself without it basically loops a certain part of a code using a parameter or a condition that is given by us. Okay, so for example, we need to find we need to find the total. So 1, 2, 3, 4, 5. Iteration way is basically we tell the program to find the total. So what do we do? We provide the length of the size of the array, and the array will loop according to the number of the size that we have provided to it, like that. Or let's say even if the array has no size, what we can do is that we tell the program to check what is the size of the array and then do the while loops. So this is numerical loops or conditional loops. Okay, another way that we can do is recursion. Okay, we can also do the same thing. We can also count the total of all these numbers using recursion. Where what does recursion means? It means a function that calls itself. To perform an operation. Okay, so let us take a look at this particular code. Okay, so let's say we have an array. Okay, we have an array. So we know that we have 1, 2, 3, 4, and 5. Okay, what we want to do for iteration, we can do it like this. So for I in whatever the array is, I in array, I total plus equal I, like that. Okay, but for recursion, it's a bit it's a bit confusing because you need to consider this. You need to recursion. You have three things. Okay, you need to have the base case, which is the start. Okay, so let's say a function. Let's say we define a function, count total. Okay, so def count total. If if we have next node, if next node exists, next index or next element exists, so what do? We return the current element, okay, the current element plus, and then we put this count total next element. Since this is not else return just the current element. What does this means is that if first we check a node and we check the function. If we have another element to check after this, so we want to tell the function to take the element and then go to the other function. We call another function so that we can take the element from that function to be added to the total. Okay? So how it works, it becomes like this. For the recursion, we'll start with number 1, 2, 3, 4, and 5. So let us begin with number 1. So we check number 1, index number 1. Is there a number 2? So we go, so first of all, we call the function, so call count total. Let us, to make it easy, just put ct. Is there another function? Yes. So we call again ct, count total for the second element. And then count total, the third element. And then fourth element. And then fifth element. Once we get to the fifth element, we found out that there are no more elements after that. So what we can do? We return. So fifth to the fourth, and then fourth to the third, third to the second, second to the first, and first we go out from the loops. Okay. So that's how it works. Now, there are a few things that you have to consider when doing recursion. Okay. First, you need to have a function, a base case function. Okay. You need to have a base case where it is a starting node. Starting element or starting node. Okay. Then we need to find a statement, a checking statement that makes it loops. Check statement condition. What allows the function to call itself. And the third one is the state of the function. State of the function. What is changed in each loop? What is changed in each loop. Like that. Okay. So let's try to do some function. Let's try to do some exercise. Okay. So let's, to make it clearer. So let's say I want to find the sum of 10 first numbers. Find the sum of 10 first natural numbers or positive integers. Okay, you can do it iteratively, and you can do it recursively. So we know that 10 first numbers have 1, 2, 3, 4 until 10. And let's say if I want to change 20 also can. So how do we do it? How do we do this? Okay, so let us just close this. Give me a moment. So let us make it bigger. So find the sum of first and natural numbers. Basically 1, 2, 3, ... until n. Okay, so iterative way, we can do it like this. So input n equals, we put n equals to input, and we change it to integer. Okay. So what do we do? If we were to make it iteratively, so this is how you would do it. I forgot how to. For I in range, okay. For I in range n, okay. So what do? We take total equals to 0. And for I in range n, this is the conventional way, the traditional way. So total plus equal I. And we print out I. And we print out total. So let's take the current file. We run them and we get how much? Let's say 10. So we get 45. So let us just put another one. Insert a number and a natural number. For example, a natural number. Okay. So for this one, iteratively, the total is. So let's do this again. So 10. So we get iteratively the total is 45. How about recursion? So let's do recursion. We do the same thing. So let's just use the same parameters. Total equals to 0 again. And now for this one, I want you to define the function. So this is the iterative way. Recursive way. So what do? We define a function, define sum n numbers okay. So what is the basic, we begin with the iteration itself. So we begin with, we want to put first we want to send a parameter to the function. So let us put n inside here. Okay, so this n is our state. Okay, now we go inside, we do some operations, and now we want to find what is the condition that makes the function calls itself. So in this case, we want the loop continues until it gets to 1. So if n is equals to 1 or n equals to 0, we return n. Okay, actually we don't need the total. Actually we return n. So for this one, this is the condition meaning that when it reaches the base case, or the case where it goes out from the loop, so we return it. If n is less than 0, we want to print an error. Okay, we want to print an error. So print error, because it is already out of the scope that you want. But this is optional, no worries. And plus, since in other cases we want it to return this, return n plus some n numbers in bracket n minus 1. This is where this is the crucial part. So we already have our statement, our checking statements, conditioning statements. If it is not fulfilled, then we return. So basically we implicitly says that, okay, if it is more than 1, then we return this. Or in other way, let us just do it like this. If n is greater than 1, return n plus sum of n numbers. Else, return n also can. So this means that this is the end. We have reached the end of our recursion loop. But for this one, we continue as long as it goes more and more and more. So for example, if it goes for 100, it goes from 100 and then plus 99, plus 98, plus 97, plus 96, 95, 94, 93, 92, 91 until the end. Okay, so now let us use this. So print sum n numbers, and we put n here. So we add this recursively. The total is like this. So when we want to add them, I forgot this. Okay, so we run this. Insert natural number 10. So we notice that, okay, now it becomes a problem. How the hell do they get for 55? 10 plus 9. Print Let's see. Let me see what happened here. It's not supposed to be. Oh yeah, I forgot. This range does not include the 10. It only includes from 1 to 9. Okay, okay, okay. I forgot. The range include 10. Does not include n itself. So this is wrong. So what we can do, we can just add 1 like that. And when we add them, so 10 and we get 55 as well. So we get this. So brother, why do you want to use recursion if iterative is better and easier to understand? There are some certain conditions, certain cases where you cannot use iteration. One of the good examples is Fibonacci sequence. Fibonacci sequence is basically a sequence where the next term can be found by adding the first two terms, first two addition. Okay, first the previous two ni terms. So 1, 1, we can start by 0, 1, 1, 2, and then 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. You cannot add this normally. You cannot get a Fibonacci numbers normally using iterative. It's hard. Okay? So a way to do this is that what we can do, okay, let us do this one. Fibonacci. So Fibo numbers. Okay? So we want to find a Fibo number. A number that is a part of a sequence. So given that the term is at a certain position, we want to find the value of that position. So what do we do? Now, we would like to see how do you want to start this. So we need to see what is the base case. The base case, we see that in some n numbers, the base case is 1. Meaning that when it reaches the base case, it ends the iteration, it ends the recursion. How about Fibo numbers? Fibo numbers, we have two base case actually because it begins with either 0 or 1. If n is 0 or 1, n equals to 1. Okay? So what we can do, or we can also say like this, if n is less than or equals to 1, okay? Because we want to say that 0 and 1 are the base case, but let's say if there's an error, let's say we provided -5 or -6, we just give them, okay? Because the important part is the positive ones. So we return n. How about the next one? Else, what do? We want to return this. We want to return Fibo numbers of n minus 1 plus Fibonacci number of n minus 2. So basically we want to find the sum of the two previous number, like that. So I'll demonstrate to you how to calculate this. Okay. So Fibonacci number 5, meaning that we want to find the fifth number in the sequence. So print the, which is n, and Fibonacci number is okay. So let's do this. So if we put 5, we get 5. Because why? Because this is n. I just realized that this is the zero term. So this is the first. Oops. This is basically the first one. This is the second one. So if let's say if I want to do 3, so it should get 2. Let's say if I want to say 10, this should be, so 10, it should be 55. You can calculate it, check it yourself. So it is 55. Also, I just need to do this. Okay. So this is Fibonacci numbers. In fact, in previous class, we already learned about recursion by looking at this. Define pre-order, in-order, and post-order. We are actually learning recursion indirectly. This is where recursion plays a role, because in tree traversal, you don't know where you want to go left or right. It is not defined. You cannot make it into an array. You cannot make a certain statement. Okay. Another good thing about recursion is that you can branch when you can set the loop whenever you want, whether you want to loop it to the right node or to the left node. Okay. So meanwhile, since I want to go to the toilet after this, so I'll just give you the code lah for the class while I'm going to the toilet. Okay, so I think that's all for recursion. We will continue with GUI after my toilet break. Okay. What was that? Okay. So now let us continue with the node. Okay, so let's just say, oops, let's just say, mana tadi? Okay, so we already have the pre-order traversal, post-order traversal, and everything. Yada. Okay. So let's say I want to create another one. Okay, I want to create another one using this. Okay, so let us do that. So let me just take all of this, copy, and we put it here. Okay, so the print order, post order, and okay, for this one, we don't need this. We already learned about pre-order and in order. So we just remove this as well as this as well lah. In order, in order, we don't need this. Let's say I want to run all branches. I want to execute all the branches of all possible branches of the tree. So let us do that. So let me see. Let's remove this. Insert node. So we don't need this. And let us just copy this. Paste. 5. Let's say this is 8. This is, I don't know, 1, I suppose. So let us just make it a bit longer. Okay. Implementing recursion in binary tree. Okay. So what do I want to do is I want the code to run. I want the program to run to all the branches and output all possible branch from the top to the bottom. Okay. So what we can do, print branches. Okay, let's say K. And for this one, since I want to I want to print the K as well as the, I think there's no need K. I want to put a string, pass. Let's say pass. Okay, so what can I do? Let me just do this. So we know that we have going to the left and going to the right. Okay, so what do we do? Print branches. Let me just check back the root. We need the sort. We need the node root, right? Okay, good. So back to here. So root, node, and pass. Okay. So what do we do? If the node has the left branch, so we go to the left branch. Node, left branch, print branches, node, left branch. And just put this. And we have the value, right? We have the value. I think we have the value. Where's the value? Okay, let's just do this. Okay, path plus node dot, what do we have? Where's the node? Where's the node? Val, node dot val. Okay. If node dot right branch, meaning that the right branch exists. So what do? We want to go to the right node and we want to print the current node, like that. Okay. I think better we put like this. Path plus equal node dot val plus, let's do this. So we put it like this and return this. Okay. So as long as it goes left or it goes right, so we print the branches. However, we want to print all of the possible branches. So we don't have the return value, but what we can do is we can check whether we have reached the if. So we want to ask the node, do you have a branch on you? Yes or no? So if it has branch, if it has a branch, so we make it true. Also this, have branch equals true. Okay, so we can go to the left or to the right. But if we have no branch, no, meaning that we cannot go left, no, we cannot go right. So if not have branch, meaning that there's no more branch, then we print out the path. Print the path. Okay. Meaning that we already checked left, we already checked the right, and there's no more. So we just print out. So let us try this. Print branches, root, sort, comma, and we have the path. The path would be an empty string. So this is the state of root sort is the state of our loop, of our function, whereas this string is an output that we want to get. So let us try this. So 10, let's see. What's the problem? Okay. So we cannot, so we change it to string. So let's try again. 10. So now we have 3 branch. The first one is 9 goes to 5 goes to 1. The next one is 10 goes to 9 to 5 to 1. And then we have 10 to 12 to 13, like that. What if I want to include 11? Let me change. So what will happen? So let me just put 10. So it becomes like this. Like that. Okay, so let's just say I put this 4 here. Copy. And then and this one I put 6. So how many paths are there? 10. So we have all the paths that we have: 10, 9, 5, 4, 10, 9, 5, 4, 6, 10, 12, 11, 10, 12, and 13. Okay, so I have taught you how to do the branches, how to print out all the branches. Now you can now learn how to print out the deepest path in the tree. So I'm looking for this one, 10, 9, 5, 4, 10, 9, 5, 6. Okay, so you may have to tweak a bit this code. Okay, so that's for the recursion. Now we go for GUI. So for GUI, I'm not going to start with this first, because this is basically the program that I made. Okay, so basically GUI means graphic user interface. All the software that you have seen in your computer, like this browser or this Python, or maybe you are watching through YouTube, right, on your laptop. All of those are software. They have graphic user interface where you can interact rather than you just put some commands and just it will run. No, it's not like that. Okay, so that is what GUI means. You can interact by pressing some numbers or anything. So for example, I have made a GUI for a stack and queue simulation. Okay, so you want to add the data into So basically I want to demonstrate how to push stack and queue into a list. How to push a data into a list by stack and queue. So let's try putting 10 here. You might not see it, you might see it. So when you push, we get the first element to be 10. So 10 has been pushed into the list. How about 40? We push it. So now 40 is in the list. How about 90? We push. How about NQ? So you have learned about NQ and everything. So we NQ. We got this. And then we pop. We have cleared our list except for number 45. Let's say I want to put some number, a name, my name, for example, Hazimat. So we push. Yes, you can see my name is clearly shown in the list. Okay, so there's also another buttons that I've put other features that we have. So we can put it clear. Okay, so let's say HD push SDC, and we want to delete certain elements, so we can just delete them. So it is very easy, because you can see there are buttons that you can push and you can input, and it will show you what is the list. So by right, this is you can call this as user friendly, because it helps you it guides you using the data, like add data into the list by either push or NQ, remove data from the list by either pop or DQ, clear the list using clear, max 12 data only in this list. And it also tells you what is being added into the list. So how do you want to do this? The function that I created is this. So many. There's a lot to cover. So let us try to do 16 or 20. So when I want to put 20, it shows 20 here. Max 20 data only in this list. So it can be very long. Okay, so for now, let's just put 20, 12 or 16. I don't know. I like number 20. I like number 5. So let's put 15, I suppose. So 1 push, 2 push, 3 push, 4 push, 5 push, 6 push, 7 push, 8 push, 9 push, 10 push, 11 push, 12 push, 13 push, 14 push, 15 push. Can we add another one? We cannot. We cannot, because the maximum is only 15. Okay. So let us go back a few steps and we learn about the demo. So what should we do? This is where you need to learn about how to use library. So from here, what I have shown you is that we have an import tkinter as tk. So it's good that we already have this library in our directory. So we just import tkinter as tk. So you just need to import this library. And sometimes if the library is too big, you need to, and you want to make it simpler, you can change tkinter to tk. This is optional. It's on you. But if you want to put as, I don't know, maybe a large T and K letters also can, or you can put another number like IIUM also can. It's on you. It's on your creativity. Okay. So now let us first begin with commenting everything. Okay. As well as this. So after we call the function tkinter as tk, so how do we want to create a window? The way is we put main equals to tk, which is the name of our library, dot tk. This is actually the function inside the library. Okay. So main is basically our function, our software or our windows that we want to show. Okay. Title is main.title. The title behind here is basically what name we want to show on the title of the screen. So let's say I want to run this. We can see that we have the demo here. Okay. So demo here can be changed. It is the title of our main window. So let us change. I want to put IIUM. Also can. So when we put IIUM, we have this IIUM up here. And then you notice that we have resizable here. Resizable means that you want to set the size of the window that you want. So you can set them to true. If you set them to true on the window, on the width, it means that you can only resize the window on the x-axis horizontally, but you cannot pull them down. How about false? How about height? If we do the same, you can also get less like that. We can change everything. Okay, it is based on your creativity, whether you want to adjust the height, let the user adjust the height or the width. Okay, so we remove this. Now we have, before we run this, you might have noticed that there's a main loop at the bottom. This is what makes our software keeps running. Okay, if we were to comment this, meaning that when we run this, nothing will happen, because we just initialize, but we don't tell them to run. So we need to start them, main loop in bracket, so we can run the window here. Okay, now let us continue. We want to focus on the frames and the grids. Okay. So frame and packing. So frames is basically a group of elements of our software that we want to put. Okay. So we have the frame 1, frame 2, frame 3. So let us uncomment them. So frame 1, we declare them as tk.frame, and we need to tell them what is your master. Frame, what is your master? Your master is main. Basically, we kind of treat them like a hierarchy. So frame, so the frame 1 is being mastered under main with the width of 100 and the height of 100 and the background of red and blue. So this is the background. These are all the parameters that you can change. There are actually more, but I'm just going to show you the usual things that you can use. We also have pad X and pad Y. This is basically the barrier, the space between each element. Okay, so meaning that pad X and pad Y means that I want you to have a margin of 5 to your left and right, and 5 to up and bottom. So let us see what does it means. Nothing. What happened? So you might have noticed we have the frame1.pack. This is where you need to learn about this. Or you need to pack. We only when we say equal, we only declare them, we only initialize them. We do not pack them. We do not put them or tell them to show themselves. So what we have to say, okay, unpack yourself. So we run and we get this. So the master mean 10, weight 10, background blue, pad X and pad Y is basically the insides of it. Okay? How many, what is the margin inside of you that you want to put the children elements inside you? Okay, so let's say I want to change the width of some colors. Okay, so if I were to put like 200 and this one is 300, you can see that we have changed. But you notice that, wait a second, isn't we declare red first and then we declare blue and then we declare green? Why the order is different? Now you notice. Because if you notice again, you have the one side left and side right here. This one tells you how do you want to pack the frames. So let us remove this and see what happens. If we were to remove this, you will get, oops, it's too short. So let me just make it a bit larger. The width a bit larger. So we get this. So they were packed by vertically in the order of their line by line code. Okay. So what happens if you want to make it side equal left, and we also do side left as well. So it means that it is going from right to left like this. Okay. You also can just not define them. So if you were to not define them, nothing happened. Okay. So let's see if I want to put width auto. There's no auto. So let's just see 300, comma, height 100. So we get this. Okay. So let's return back to normal. Right, and then this is left. And you just make this to 200. 200. As well as this 200. So we get this again. Okay. So this is frames and packing. Now, we have learned about frames and we have learned about how to pack. So let us do grids. In grids is very useful if you want to make a grid. Okay? And usually grids lets you use the for loops, because grids is basically a 2D array or an array. Okay? So what you can do, let us uncomment this. So what do we see here? For I in range 4, I in range 5, we want to tell the frame grid to create a frame, okay, where the text is the label here. Now we are going to learn about text. We have learned, so grid, labels, and relief. Okay, so frame grid, TK frame, text equals TK label. Okay, so we see that the frame grid has the master of main, and now we see the text, we have the label of master equals to frame grid, meaning that this text, this label is master to frame grid. There's also other what do you call it, other elements we will learn about more, which is the button and also the text input, the basic one. So master, frame grid, text, F. So text equals to, we've learned about the literals. So we put the string here. and then we put the width, which is 10, and the height, which is 5. And now we are going to learn about relief. So relief is basically how you want to show your labels, okay, whether you want it to be raised or relief or more. So we have groove, raise. The 3 more is on you for you to discover yourself. So let us try to run this. So when we run this, we have this. It shows this row 0 and column 0, row 1 and column 1 until row 3 and column 4, like that. So you can change this as much as you want. So when I put 10, it becomes long. When I put 10 also here, it also becomes long. This big. Okay, so but for now, let us just go back to 5 and 4. Like this. Okay. And then we have the text.pack. Okay, as usual, the text should be packed inside the frame grid. Every element that you want to show, you need to tell them to pack. So text.pack, and then this is where the grid comes in. Frame.grade, so you want to tell them, okay, the grade you need to put the frame grade at the position of 0 at the column of 0. There's also some others like row span. We have row span, we have column span. Okay, row span means that how many cells do we want the frame to cover, either horizontally or vertically. Okay, but for now we are not going to focus on that. Okay, so we have learned about the basics of grids and labels. So now let's see about some other things. Okay, so let us see. Now we are going to learn about button frames. Okay, so if we only show the software which is not interactable, it is basically useless. So you need some buttons to make it interactable so that the user can enjoy the experience or can utilize the software. So two of the most useful functions are text input and buttons. Okay, so text input, basically button frame. Okay, this is button frame, so we just uncomment them. So master main, the width is 500, the pad is 10, the pad y is 5. So when we run this, we have nothing. But it's okay because the height of the button frame depends on its elements. So let us go one by one. So the text input basically lets you input. Okay, lets the user put an input. So you put text equals to tk.entry, and we want the master to be button frame. So text input is being mastered to button frame, and the width is 15. So when you run this, you get an empty entry text input, but you cannot do anything about it. So we need a button for the function to read the input that we take. So what do? We create this. So button 1 equals to tk.button, and then in bracket master dot equals to button frame, and we have the button click me. So basically these are all the parameters that we want to show them. So the master is button frame, the text is click me, and the width is 10. And you notice that there is a command here. Okay, so this is where we want to tell this is basically what we want the program to operate by clicking the button. So if you notice, on top of our code is this define show label. So we need to define a text label, okay, where data equals to text input get. This is where we want to take the text input. Okay, text input pack side left. So we take the text input, we get the input from them, and we print the data, and we also want to show the data. So now we go for the text label. This is where we want to configure the text. Okay, just now we only show the text labels. We only show them, but they do not change dynamically. Okay, so we want them to change dynamically. So let us introduce text label equals to tk.label master button frame, and we want the text to be empty, but the height to be 2. So button frame text click me. So we go back to the show label. We see that, okay, after we get the data, we want to configure our elements just now to put some data there. So text label config text f data has been entered. Okay, and then we want to pack the data, meaning pack the data here means you want them to show. It also means that we want them to update. Okay, so let us run this. So we have a demo here. So we put, let's say, IIUM. We click me, and it shows IIUM has been entered. Let's say if I want to put Ziman, my name, also can. It also shows that. If you want to put, I don't know, long input, also can. It will take the input and will output there. So that's basically the basics of GUI. Okay, so inshallah, next class we are going to learn in depth about GUI, where we are going to read my code on this particular, okay, where this is basically you combine what you have learned before, the close and class notes, and you get to learn some new things in GUI. Okay, we have the clear input. It becomes very complicated, so we don't have time now. So I think we can end our class here. So for you guys, now you can start developing your task 5. Okay, I've shown you about the recursion, so you need to learn about them. Okay. Okay, with that, Assalamualaikum warahmatullahi wabarakatuh.